Let's talk about one of the biggest paradoxes in machine learning. You see all these amazing projects, these brilliant ideas cooked up in a data scientist's notebook. But why do so few of them ever see the light of day? Why is it so incredibly hard to get them into the real world where they can actually do some good? Well, we're about to dig into that.
I want you to just look at this number for a second. 87%. Just let that sit there. In this high-tech, cutting-edge world of data science and AI, what on earth could a number that high represent?
That's right. That's the failure rate. An absolutely staggering 87% of data science projects just never get deployed. All of that work, all those amazing insights, they just kind of evaporate. This isn't just a small problem. It's a huge crisis of wasted potential. So, that really brings us to the big question for today, doesn't it? Why is that journey from a cool experiment to a live product so difficult? And, maybe more importantly, what can we actually do to fix it? Let's break it down.
All right, here's our game plan. First, we're going to nail down the core problem. Then, we'll introduce a solution called MLflow. After that, we'll walk through what a real workflow looks like, and we'll wrap up by peeking into the future of MLOps. Sound good? Let's jump in.
So let's get right to the heart of the matter. The fundamental issue here is that building an ML model is not at all like building traditional software. It's a whole different beast. And this slide really lays it all out. See, on the left, you've got traditional software. It's a pretty clear path, right? You change the code, you run a test, and it either passes or fails. Boom, done. But then you look at the right side. Machine learning. It's all about experimentation. You could change one tiny line of code or just feed it slightly different data, and your results could go flying all over the place. You're not looking for a simple pass-fail. You're chasing this constantly moving target of better performance. It's messy. And it's exactly this experimental chaos that MLOps, or machine learning operations, is designed to solve. The tool we're going to focus on is MLflow. The best way to think about it is as a system that brings some much-needed discipline and order to that creative but often chaotic ML lab. So what exactly is MLflow? At its core, it's an open-source platform designed to manage the entire machine learning lifecycle, from start to finish. The goal is pretty simple, but incredibly powerful: to make good results repeatable successes, not just happy accidents. Its first major component is tracking. Honestly, this is like your digital lab notebook. Every single time you run an experiment, it logs everything for you: the parameters you used, the exact version of the code, the performance metrics, and any files it created, which are called artifacts. It totally gets rid of that, wait, which version of the code gave me that amazing result again? Headache. Next up, we have projects. And the keyword here is reproducibility. An MLflow project is basically a standard way to package up your code with all its dependencies and configurations. What that really means is that anyone on your team, or let's be honest, you, 6 months from now, can take that package and rerun your experiment and get the exact same results. That is a game changer. Okay, so you've got a model you love. Now what? You have to actually use it, right? That's where the models component comes in. It gives you a standard format to package up models from pretty much any ML library. Think scikit-learn, TensorFlow, you name it. And then helps you deploy them to all sorts of places, whether that's in the cloud or on your own servers. And finally, there's the model registry. This is the central source of truth, the library for all your team's models. It lets you keep track of different versions and manage their entire lifecycle, moving them from a testing environment or staging into the real world or production. It's all about having control and knowing exactly what's going on. All right, we've looked at all the different pieces. Now let's see how they all click together in a real workflow. This is how you actually go from just an idea in a notebook to a live model that's out there making predictions. It really boils down to these 4 main steps. First, you use MLflow Tracking to log all your different experiments. Once you find a version that works really well, you package that code up as an MLflow project so it's reproducible. From there, you register that winning model in the model registry. And finally, you can serve that model, making it available for your application to actually use. Now, you might be thinking this sounds like a lot to set up, but here's the best part. For a lot of the libraries you're already using, you just add one single line of code to your script, mlfo.sklrn.autologging. That's it. You add that one line and MLfo automatically starts tracking everything for you. It really is that simple to get started.
But this whole framework isn't just sitting still, right? It's constantly evolving, especially now with the massive large language models, or LLMs, that are changing everything. So let's wrap this up by looking at what's coming next.
You see, LLMs come with their own unique set of challenges, and MLflow is adapting to help out. First, it helps you test and evaluate these huge models without having to do a full, expensive deployment every time. Second, its AI gateway acts like a universal adapter, making it super easy to switch between different model providers, like OpenAI or Mistral. And finally, it gives you one simple, unified way to interact with all of them, which saves a ton of headaches. So, if you remember just 3 things from all this, make it these. First, MLflow brings reproducibility, which means your work can actually be repeated by others. Second, it fuels collaboration by giving your team a central hub to share everything. And third, it drives efficiency, helping you automate the boring stuff and deploy faster, so you can finally beat that 87% failure rate. And that really leaves us with one final thought to chew on. We all know that AI is only getting more powerful and way more complex. So the question isn't if you'll need a process to manage it all. The real question is, how are you going to build one that's ready for whatever comes next?